Hi everyone, today I'm going to show you how to configure GLBP. GLBP, or Gateway Load Balancing Protocol, as you know, has been implemented in order to create gateway redundancy between the routers or layer 3 switches. In this lab, we're going to configure router 1 and router 2 with a virtual gateway IP address on the 172.31.1.0 network in order to achieve the gateway redundancy for PCO1. So without further ado, we're going to jump into the configuration of R1 and start. So the first thing we want to configure the IP addresses, since we haven't done that yet. So on interface path Ethernet 00, we're going to have an IP address of 10.1.1.1 with a mask of 255.255.0. Ensure the interface is not shut down, then jump into the configuration of FA01, give an IP address of 172.31.1.1 with a mask of 24. Make sure this is not done. Right. Save our configuration and jump into the configuration of router 2. Alright. So the IP address of this interface is going to be 10.1.1.2 with the mask of that. Shut down that, and then FA01 P address of that one's going to be 172.31.1.2 0. Alright, so as you can see, we already configured our IP addresses, and now we're going to configure a virtual gateway IP address that will allows us to have gateway redundancy between these two routers on a 172.31.1.0 network. In order to achieve that, we're going to jump to the configuration of the fast internet 01, and we're going to have a GLBP. So we're going to give it an ID. This really doesn't matter, but this ID is globally significant, which means that if you're using a 204 or any number, that identification number needs to be used also in the same router on the other route, on the other side of the router too. So if we use the 204 on this router, on router 1, and when we use 205 on router 2, we will not be able to achieve the goal that we are going to try to do. So we have to make sure that we're using the exact same number as an identification number. So GLBP 204 IP, and that's going to be 172.31.1. Let's say we're going to pick 3 at this time, 255.255.255.0. As a matter of fact, we don't need to provide a mask. And then we're going to go to the router 2. Do the same thing on fast Ethernet 01. GLBP, remember the identification number has to be exactly the same, so 204 IP and 172.31.1.3. So soon we should get basically a message that says that whether our router is going to become an active or a standby for the GLBP domain. So try to ping the 172.31.1.1 first. Let's try if we can. That, yep. And here we go. So now, as you can see, the GLBP group came up, and then if you do a show GLBP, we should be able to see if our state is active or standby. As you can see, our state on fast Ethernet 01 is active. Let's write our configuration and jump into router 1. And do a show glbp. So basically it stays in its peak, so that means that we still haven't had anything to determine the router to be on as either an active or standby. Okay, here we go. Now we have the router 1 as in a standby router. So as you can see, we have achieved the goal of having the virtual gateway IP address shared between these two routers of a 172.168.1.3. So if we ping that on both routers, we should be able to basically get a reply back. So if I ping to 172.168.1.3, I'm able to achieve it. And at the same time on router 2, if I do the same thing, ping 172.168.1.3, I'm also able to get to it. Okay. So here we do not have a DHCP server in order for this PC right here in the bottom of the screen to get an IP address. So we're going to use router 1 as a DHCP server. In order to set this router as a DHCP server, we need to create a pool. So basically we're going to create an IP DHCP pool. Let's call it networking labs. Okay, and let's do a DNS server. We're gonna have the 172.168.1.3. We're gonna have the network on 172.168.1.0 with a mask of 255.255.255.0. Okay, and then we have going to have the default router of 172.168.1.3. And the reason that we're going to set it as the 172.168.1.3 because that's going to be the gateway IP address that's going to be given to the client, and that's what exactly we want the client to have. We don't want the client to have any of the IP address of the 172.168.1.1 either 1 or the 2, because that way if one of these routers goes down, the clients would not be able to reach them. However, if we put the virtual gateway IP address of the GLBP domain, then we will have the ability to reach either router, whether one of them is down and the other one is up, or vice versa. So we're going to also enable DHCP service, service DHCP, and we should be good to go. All right. So now we jump into the configuration of our client. All right. Let's see what options do we have here. So we're gonna have basically IP DHCP. Try that. See what IP we have. Okay. Now we have our IP address. So if we ping to 172.168.1.3, you're able to ping it right there. At the same time, if you want to see exactly what IP address is, so our gateway is, as you can see, we got an IP address of 172.168.1.4. Our gateway IP address is 172.168.1.3, which is the IP address of the virtual gateway which the GLBP provided for us. So now one of the tests that I'm going to do is actually I'm going to turn off router 1, actually router 2, let's say, or router 1, and see what happens. So as you can see, we no longer have connectivity to the router 1. So I'm going to try to see if I still can reach the gateway address. And here we go. And if we do check the status of R2, we should be able to see that this router is now in an active state. So if we do a show glbp, we'll see that the state is active. Well, I hope that you guys enjoy this lab. We will do more in depth in the future labs. Thank you for watching.